In this tutorial, we're going to take a look at how to incorporate 3D models into any React application using React 3 Fiber. We're going to build a nearby plane tracker so that you can see planes that are near to you.
Wow.
And we're going to do so using a 3D model of the Earth and a 3D model of a plane. Hope you enjoyed the tutorial and welcome to the channel.
Alright, so welcome to the tutorial. Here is the overview of what we're going to go through today. So let's look overall on the project, the package that we're going to use and the markup and so on. Create a Starry background, convert some models to JSX, render an Earth, a marker, some planes, fix the rotation and color of our planes. We're going to implement functionality so that you can click on the Earth and zoom in and out. We're going to rotate the Earth to the selected marker, and then we're going to add geolocation of the user and then fetch some real planes from the OpenSky API. And then calculate some cool information for the plane that you're currently watching. That should be it. So let's start with the overview. So let's look at the packages. So we have React Spring for 3, which is an animation library. We have React 3 Dry, which is some utilities, the core renderer of 3D things, which is React 3 Fiber. And then we have React DOM, React scripts for the bundling and web server and so on, since this is a create React app start. And we have 3. So let's look at the current markup that we have. We have a title, a canvas placeholder, and some control panel. So this is what it looks like. This big square is the React 3 Fiber canvas. It's not yet, but it's going to be. And here, down here, we have the control panel. And here we just have a title that is floating on top of the canvas. So inside of the control panel, all we have now is some information about the current active marker that we're watching. We're going to come back to this later, but the main state of the application is a list of markers, and that is a combination of you and more markers which are planes. So right now I just put one marker with the ID of me, and that has lat long 0, 0. And we have another piece of state that's called active marker ID, and that is defaulted to me. So as we can see in the browser, the active marker right now is us. So the control panel is showing that we have one marker, type is person, and lat long is 0. And the next and previous buttons are disabled now because we only have one marker. So if we look here, disabled if markers.length is 1 or less. So I think that covers the overview. Our first step is to create a star background. And in order to do so, we need to replace the canvas placeholder with the actual canvas. And that canvas comes from the React 3 Fiber package. So let's render this canvas here. So we have a canvas to put 3D stuff into. We have some style that we need to put on this canvas. If we look at this canvas placeholder, that has a height and a width that we want to copy over to the real canvas. So this -6 pixels, that was just for the border, the pink border that I had. So we don't need those removed anymore because we don't want to have a border. And the height will stay the same. We just subtract some space for the control panel. So now we should have a real canvas in the placeholder's place. We're also gonna put some stars on this canvas to verify that it actually works. So the stars we're going to get from dry, and it's very simple. We just import it and we render the stars component. So now we should actually see something here. Ooh, now we have a real 3D canvas and we have some stars that are twinkling. So that covers another step in our tutorial. So let's check that one. So now it says convert GLTF models to JSX. And in this tutorial, we're going to use two different models. One is of the Earth and the other one is of a plane. So we need to go download these. And here we have the airplane model. And the other model is linked here in the README, which is the Earth model. So let's open up the Earth model as well. So let's start with the Earth model. It looks like this. It's created by Patel Dev, and when you use it, we need to give attribution to the creator. So that attribution is in the README. So the format that we want to download here is GLTF. We download that, and we see that we get some files here. And this is what they look like, and I am going to take them and put it in the public folder of our code repo. Earth license. So as we can see, these files are called scene, and since we are going to be downloading two, they're going to conflict, so we need to rename scene to Earth. But one thing to be aware of is that the scene.bin is referenced here, so we need to rename this reference as well. So we'll rename it to earth.bin like that and save it, and now we can safely rename these two. So earth.gltf and earth.bin. Great. We also have a textures folder that we got with the Earth, and if we open this JPEG here, we can see that this is the texture that is going to wrap the sphere that is the Earth. So before we can use this inside of React, we need to use a converter. There's a package for that. So if I step into the public directory and I reach for the package gltf.jsx, and then I point it to earth.gltf, it will create a component for us. So now we have earth.js here that we can place in our components folder. So let's import Earth into the app. But let's see what we have inside Earth. So we have some info about the model. We have a group, a rotation, and I think we should be able to just take this and render it. So we place it inside the canvas. But there is one thing missing before we can see this Earth. And that is a light, because if you are observant, you can see in the middle here, it's just a black hole. And the Earth is not a black hole. So we need to add a light inside here. So we'll add a point light. And let's place it 10, 5, 10. There we go. So now the Earth is illuminated. It sort of looks like the sun is shining on it. But the Earth is a bit small in my opinion. So what we can do, let's first just clean up a few things that we're not going to use here. And these props will remove. So to the outermost group here, let's add a scale. So let's add scale 2, and we just doubled it in size. I also see that there are two inner groups here, where one is doing a rotation on the x-axis for minus math.pi divided by 2, and the next group does the exact opposite. So these two groups should just cancel out. So if I try to remove those two groups to clean it up a bit, we should see that we have the exact same, because they were just canceling each other out. All right. So we have a working Earth model. Let's do the plane model while we're at it as well. So we have this airplane created by Omar Mohammed, attribution to you, also in the README. So we download it, just the exact same process. It will be called scene again, like this, and I will take the file and place them inside the public folder. So same process again, see if it references scene.bin, and it does. And we'll call it plane.bin, and then rename it plane.bin and plane.gltf. All right, so now it's time to do the conversion. Plane done, and let's move it into components. So this one I will render next to the Earth here. Plane from plane, and we'll wrap this in a fragment and render the plane here. And let's have a look. So if we look inside the plane component, let's clean up a few things that we're not going to use. There we go. So you always need to look through what's been generated here. So something that sticks out to me here is that the cylinder position is moved upwards by 300. And that's the y-axis. So it might be that this plane is really high up, and I think it was. So now it's centered, but it is really, really huge. So let's change the scale of this plane. So let's do 0.1, and it became smaller, but it's still huge. So let's take it down another factor 10. It's still pretty huge. Let's rotate it, and I always have to guess which axis to rotate it. So if we start with 0, 0, 0, let's try for the x-axis, and this is in radians. So we do math.pi, and since 2 pi is a full rotation, half a pi is half a rotation, or 1 pi is a half rotation. So 2 pi is 1 rotation, 1 pi is a half rotation, so half a pi would be 90 degrees. So let's try to rotate it 90 degrees. Rotation. All right, so that's good. It looks like we got a top view there. So let's also change the position a bit. So we want the plane to come towards us, which means the Z axis. So we'll do 0, 0, and let's try 2. So it came towards us. The scale is still crazy. So if I look here, I can see that The scale is 100 here, so let's try changing that to 1 instead of 100. And let's try moving it closer to us, because now it might be inside of the Earth. There we have it. So it's starting to look decent here. The next thing, what's the next thing that we're going to do? So we took our models and they have been converted to JSX, so that step is done. We have done the Earth, we have done the planes. We're also going to create a marker that is not a plane. So by a marker that is not a plane, what I mean is if we want to show the user location, we don't want to show it with the plane because that would just be confusing. So I will show you one way of doing that. So on the Earth component here, let's render out a mesh. And inside the mesh, we're both going to put a geometry and a material. So we're going to put a sphere geometry. Sphere geometry. And we're going to put a mesh standard material. So for this material, we can pick a color. And I am going to pick orange. And for the geometry, we can specify a size with the args prop. So here we can set the radius and let's set 0.1. And with this mesh, we can set the position. And I do know from the plane that we need to increase the Z a bit in order for it to not end up in the middle of the Earth. So I think I used maybe 4 or something. So let's see if we can get this mesh to appear. And there we have our sphere geometry with the orange color. So I think this, for a marker, it's still really, really big. So now it's placed inside of the plane. So now we have our components. We have the Earth, we have a plane, and we have a marker. So now we are done with these 3. So the next thing that we're going to work with is the rotation and color of the plane. So we're not yet fetching planes from the API. So I think we should create a fake plane in the markers list. So let's make up an ID for it. It will, from the API, it will be like hex strings. So we could say AA01BE, that could be a valid ID. And let's just make it 5 and long 5, so it's not in the same place. And type, let's add type now, so type is plain and type is human. Alright, so now we have 2 markers. So then we could also actually try out the control panel. So we see that we have 2 markers. The first one is a human and the second one is a plane. And the logic for that is just this type here. If active marker type is plain, the plane emoji, or otherwise the human. And we will display the lat long and just the marker index. So we already fixed the rotation of the plane. The other rotation we're going to need to do once we start to get data about the plane, because then we can figure out what direction the plane is heading. So then we can calculate what the rotation is. But we can fix the color of the plane right now. Each unique plane should get a unique random color. and that should be based on the ID that the plane has. So what we're going to do is that we're going to go into the materials from the model, and I know that the body of the plane is called material 001 that has a color object. So we can modify this color object, and this color object has 3 props. It has R, G, and B. So let's start with the R. So we have this ID, and if we take the first 2 letters in this ID, we can, since it's 2 hex values, if we do parse int with base 16, we will get a random number between 0 and 256. So I'll do parse int and base 16, and this material color should, each R, G, and B should get a number between 0 and 1. So I need to divide it by 256, and then we will land somewhere between 0 and 1, since the parse int of these 2 hex values will be somewhere between 0 and 256. So I'll just duplicate it for G and B, and let's look at different slices of this ID for the different colors. So I think this is a nice deterministic way of getting a random color for each plane that it will keep. Alright, but right now we're not passing in an ID to a plane, so let's just try something. So we have the plane here, and we'll say that ID is equal to, we can take this one that we made up, and now the plane used to be green, but this ID ended up making the plane pink. So that is going to work well for us once we get real planes with real IDs. Alright, so moving on in the list, we'll call this one done for now. The next item is to zoom the Earth when we click it. So we need to keep track of if the Earth is zoomed in or not. We can also rename this from model to Earth to be more clear. We can also do that with plane. So let's import the useState hook. So we'll do const is zoom set is zoom. We'll default that to false. And let's add an on click to this outermost group here. So all we need to do is call set is zoom, take the previous value and return the opposite of that. So now we should have is zoom. So every time I click the Earth now, we should toggle this back and forth. True, false, true, false. That's great. So we want to animate the scale of the Earth depending on the isZoom value. So what we need to bring in is the useSpring hook. So we will import useSpring and this A, and I think the A stands for animate, and it's something that you can put in front of the tags that you plan to animate. It means that useSpring will take control of it. So we will call the useSpring hook and give it an object. And we'll set a scale prop here. And right now we have scale 2. So we'll say that if is zoom, then do scale 4, otherwise do scale 2. So we need to destructure scale here from what the spring is returning, and replace the scale here with the spring scale. So now let's try it and see if we can click the Earth and zoom in. So now we have the zoom in functionality, and as we can see, we need to also move our marker and plane according to the zoom. So what we can do is that we can set a marker position inside the spring as well. So if it's zoomed, we want to move it closer to us. Otherwise, we keep the default value that we have now, and what we have is 4. So we can do 0, 0, 5 maybe if it is zoomed in. And let's destructure out marker position, and we'll add that to our marker here. So instead of this, we say marker position. So let's see if it works for the marker. We need to add the A dot to this mesh for it to work. Alright, so we see that it is in fact working, but we're moving this sphere geometry a little bit too much. So let's see if we can have this as like 4.5. I think we can probably lower this a bit. Yeah, so it's hard to see if it works now when the plane is in the way. But we're going to do it for the plane 2. So we'll say position prop, and we'll pass in the marker position. We need to import just this A for now, so that we can receive the position and use it here, and add the A to this group. So now we put the same animation on the plane. So let's see what happens. Yeah, so they animate together and they seem to follow the Earth pretty good. I would probably like to just take them down a tiny bit more. So let's try 2.5 here and see if they are still above the surface of the Earth. Yes, that felt a little bit better. So then we are done with the zoom Earth on click. So now we move on to the rotation of the Earth. So what we want to do is that the Earth should receive a marker and adjust its rotation to the long lat of that marker. So we'll say that we pass a prop called marker, and we pass in the active marker. So right now we set the active marker to me, and me has 0, 0. So we need to figure out where is long lat 0, 0. Lat long 0, 0. And that's on a place called Null Island. And if we Google for some pictures, we can see that it is outside of the coast of Africa, and we can have these 2 points as reference points. So it should be a tiny bit above this point, a tiny bit to the right from this point. So let's receive this marker, and we can take out the lat lone from this marker. And let's add the rotation to the spring so it animates nicely. So this is something that we need to calculate now. And the hard part is that lat long is essentially degrees, and what we need to pass to React 3 Fiber is in radians. So we need to do a conversion here. So we'll say lat rotation is equal to lat times math.pi divided by 180. And for the lone, what we need to do is flip it. And what I do know, because I've used this Earth model before, is that it is offset by 90 degrees. So let's store that in a constant here. Long offset is, so 90 degrees would be math.pi divided by 2. So let's use these in here and 0 for the Z axis. And let's destructure the rotation. And let's put the rotation on this group here. Rotation is rotation. So if things went correctly, we should see the null island being under the marker and the planes. And if we look at this point here, it looks quite correct. And I think from this point also, it's also quite correct. So I think we are on track. So let's try with this plane and the other plane that we have. We can take a known coordinate and see if the Earth rotates to that coordinate. So let's take lone lat New York. So we have 40.7. And for the lone, we have minus 73. So now we should be able to switch using the control panel. Yes, and we moved to New York, in fact. So great, we can switch between Null Island and New York. Pretty cool. So does that take another item in our list? Rotate Earth to selected marker. Yes, we can do that. So our next step is to geolocate the user. So I have this hook here that I stole from another project. So it's called use geolocation, and you just call it and you get a location back, or first you get null back. And then you wait for the navigator geolocation to get the current position. And then once it has it, it will no longer be null. It will be, we should name this lone. It will say user geolocated and print it out and then set that location. And if this doesn't work, it will say this site needs geolocation to fetch planes around you. So let's call this hook from the app here. user location is use geolocation. So this will be null first, and then it will be a real location. So when we declare these markers, let's check if user location is done. If it is, we can spread these in here. User location. And if we don't have it, then we can just keep this sample plane. And let's default to the plane instead of the user. So now we see we have one marker, and then we have two markers. And that it changed because we are placing the human before the plane. So once it finds it, the plane is no longer at index 1, it's at index 2. But now let's see if I switch to the me marker, if it jumps to where I am in the world. And it does. So this is where I am. So what we want to fix now, since we have a person and the plane, we can fix so that we render the plane for the plane and the marker for the person. So we can fix that inside of the Earth component. Because we receive a marker here that has a type. So if marker.type is equal to plane, we want to render the plane. Otherwise, we want to render the marker. So let's see. Okay, so now I'm on a person, so we should render the orange dot marker. And when I switch to a plane, it changes to the plane. But I think now it could be time to start looking at some real data from the API. So here is what the API looks like. So you call state/all, you get an array of planes, and each plane is also represented by an array where the index means different things. So 0 is an ID, and then we have origin country, long lat is important, and then we have category and so on. So we will save a few of these attributes, and I took the liberty of saving 2 requests, and they are separated in time by like a minute. So before we do the real request, we could actually use these 2 sample requests. But let's use the sample data inside of this usePlanes hook that I plan to use for fetching planes. But one thing that we need to fix is that since we have 2 samples, we want to, the first time we fetch, we want to fetch this first sample, and the second time we fetch, we want to fetch the second sample. So let's add a piece of state to keep track of our fetch count. So we have useState, and we'll start at 0. Let's declare a function called fetchPlanes, and we'll wrap that in a use callback. So if fetch count is smaller or equal to 2, or I mean larger or equal to 2, that means that we fetch twice and then we don't have more sample data. So we just want to return. Otherwise, we can set these planes to the next sample data. Set planes. So we do set planes, sample planes, fetch count. So we'll destroy this. So we initialize to an empty array, and then we're going to call fetch planes, and we'll get the first sample, and then we need to update the fetch count. So prev +1, and then the second time it will do the next sample, and then we're out of samples. Fetch count. So we need to handle a few things here, because it might be that some planes are new, some get removed, and some should just be updated. So we should fix that when we're going to fetch these planes. But first we should map over these sample planes, because this is raw data in the shape that the API delivers it. So we don't want to keep all of this, and we want to, instead of an array, we should use an object so that it's easier to work with. So we'll do a mapping of all these planes. So we can dig out some properties from plane here. We saw from the API that the first thing in the array was the ID. And then the origin country is interesting. So we skip one and we take the origin. And then how many do we want to skip? 1, 2. We skip 2 places and we go for the longitude. Skip, skip, and then we take the lon, and then we take the lat. And I think that's all we want. And then we return an object. So we take all of these. And of course this is going to be a plane, so we add type plane. And we're also going to handle, once we have seen more than one coordinate of a plane, we want to figure out how do we rotate this plane so that it aligns with where it's going. So if the previous coordinate was straight south from it, we want to have the plane face north, because then it came from the south and the direction should be north, and we want to rotate it accordingly. But if this is the first time we're reading this plane, then we don't know about the rotation. So we'll set it to 0 for now. So now we have an array of all the fetched planes, but they are structured in an object instead of an array. So we can filter out which planes of these fetched planes were new. So the new planes would be, we can do this inside a set planes call, where we get the current planes, which is the previous state. So we can compare the fetch planes to the current planes and filter out just those that are new. So we can take the fetch planes.filter, and for each fetched plane we check if current planes, if some of them, if some ID in there is equal to the fp.id, and we should check that they are not there. If they are not, if that ID is not seen in the current planes, it means that it is a new plane. So now we have a list of all the planes that are new, and those we just want to add to our state. But we also need to check for all the planes that already existed in our state, because those are the ones that we can calculate the rotation for. Check for existing planes in state and calc rotation. Const existing planes. So here we can do something very similar here. So essentially we do the same thing, but we check for those that did exist in the current planes. So on these we want to do a map, and the only thing we're going to change in this mapping is that we calculate the rotation. So this is our fetched planes, which means that this is the latest lat and lon. So we also need to know the previous value of lat and long. So that we can do like this, current plane. So we look in the current planes and we find this plane.id, and from that we can structure out lat as prev lat and lon as prev lon, and the rotation as prev rotation. Current plane. So now we have everything we need to figure out how to rotate this plane. And rotation is equal to, we also need to verify that either the lat or lon changed, because if we have the exact same coordinates again, we have the exact previous coordinates as we have the incoming coordinates, then we still cannot calculate the rotation because the plane has stood still in the data. So we make sure that lat is not equal to prev lat or lon is not equal to prev lon. If that is the case, then we can calculate the rotation. But if they were the same, then we just have to keep the previous rotation. So this calc rotation function is a function, these two functions, both calculating the distance between lat and long pairs and calculate the rotation of two lat long pairs, are functions that I have not written myself, but they seem to work great. So here we pass in lat 1, long 1, lat 2, long 2. Long prev lat, prev lon. So we need to import that function as well. Calc rotation. All right, so we also need to return from this map, and that will still be an object where we spread the plane and we set the rotation. So now we can say that our new state for the planes is the new planes and then the existing planes. So let's make a little log for ourselves here so that we see what's going on. So we can say that existing planes dot length updated and new planes dot length added. So now we can see how many planes existed, but we just calculated the rotations or updated them, and how many were added. So now all we have to do is return this new state from the set planes function. But I also would like to sort them based on the distance. So in order to figure out the distance, we need to utilize the user location inside here. So if we have the user location, we can say that distance is equal to calculate distance lat lon, and then we can take the location, which will be the user location. So we just need to make sure that we pass in the user location to this hook and import the calc distance function. So now we can store the distance to the user for every plane. And when we have that, we can take our new state and sort it. So we return a.distance minus b.distance. All right, so I think we have a working plane hook here. Here it should be fetched. This variable is called fetched planes, so here it should be fetched planes, and here it should also be fetched planes. All right, so let's use this hook inside of the app component. Const planes is usePlanes, and we need to pass in the user location. So we also need to handle in the usePlanes if the user location is not found. So we could say we pass in the user location, or we pass in lat 0 lon 0, so it will never break. So now instead of this sample plane, we could spread in planes. So this needs to change now. So I see what happens here. If we don't have an active marker ID, then active marker will be undefined or null. So we'll pass that in here. So what we could do is that we could just pass in, if we don't have the active marker yet, we could just pass in the null island. And then we could actually set this to me. So now we'll wait for the user to be geolocated, and then we start. Okay, so we're not receiving any planes yet because we're not calling this fetch plane. So let's do that in a use effect here. Fetch planes. So let's see, now we got 50 planes. So we have some console logs here. We see that 0 planes updated, but 49 were added. So we run the fetched planes once. I think if we were to add location here, we might run it actually twice. So now we see 0 updated, 49 added, 0 updated, 48 added. So let's make sure we have all our dependencies correct. So this one uses fetch count, and set fetch count, and set planes. And it also uses location. This one should have fetch planes. All right. Oops, here we have another set planes that should really not be there. All right, let's see what happens. So now it looks more correct. So the first sample, we have 49 planes added. And then on the second sample, we have 48 updated. So we saw that one plane must have flown out of bounds. So some plane left the bounds in which we request planes from. So that looks good. So now we can see we have a lot of planes here. So let's add the distance to the control panel. So we can say that if marker.type is plane, then we know that we have, for example, the distance and the origin and so on. We can do distance in kilometers, and this needs a fragment. And this should be active marker. And we can also add origin. So if we switch to a plane now, we get the distance, and it's a plane that came from Poland, and it's 6,221 kilometers away. Wow. And we'll set these in a div. There we go. So the final step is to implement the rotation that we calculated so that the plane is facing the correct direction. So we can pass in the rotation here. Because we have that in Earth. Rotation marker dot rotation exists. So we receive rotation, and that should of course be animated. So now let's import use spring. Call it rotation. So this is what we're starting with. So I suspect that we need to put the rotation on the y-axis here. Let's call these ones plane rotation. So now we can replace this value with plane rotation. So let's see what happens. Okay, change direction at least. And it says it came from the Netherlands, so that could be correct. This one came from Denmark. This one came from Norway. Came from Sweden. From Ukraine. Yeah, I think it's probably correct. So now we have the rotation. But one thing that is not so nice is that it looks like it's always the same plane. So one way to fix that is to play with the scale of the plane. So we could do a spring here from scale 0 to scale 1. And let's add a config of duration 500. So we have the scale, and we want to trigger this whenever the ID changes. So we can put a use effect here. So whenever the ID changes, we want to do scale.reset. So let's see if that worked. And it was not to 1, it was 0.01. And we need to remove the old scale here. So let's see what happens now. So it seems like there is something wrong with the ID, because I also see that material is not changing. So let's look inside of the Earth. Oh, we hard coded the ID here. So we'll do marker.id. So now we also get some new colors, and whenever we change the plane, it sort of appears from the ground. So now it looks a lot better. So let's look through our tutorial to-do list. The only thing we have left is to change this to actually fetch real planes. And we already prepared for this, so it won't be too hard for us. So instead of getting the planes from here, we just need to fetch the planes. So we can remove these fetch count things. And we want to do this mapping on the real data instead. We just need to get the data first. So we can do a fetch, and let's get the URL. So here we have the base URL, and we need also to say within what long lat boundaries do we want to get planes. So we do the base URL, and then we do a query parameter. We do LA min is equal to lat minus bound size, and then we just continue this pattern for LO min equal to long minus bound size, and for the LA max and LO max we just add the bound size. So this returns a promise, and in that we get a response, and that response we read the JSON response, and that returns a promise, and in there we get the data. So now we need to wrap our whole function in this fetch. So let's refresh. And now we have, wow, this is live data coming in. So the final step would be to have this run on an interval so that we can figure out the rotation of them, because now they're all facing just south. So we need to get 2 requests in before we can calculate the rotation. So let's use the use interval hook here. Use interval. And that will be just the same as this. And we tell it to run every 10 seconds. So this is a hook that just takes a callback and a delay, and it will execute the function on that delay on every interval. So here we should have 10,000. So our first planes are in. And now they got their direction. So pretty cool. So that's all I wanted to show you today. Thank you so much for those of you that reached this far. It got a bit complicated in the end with the calculation of the distances and rotations, and I hope you learned a thing or two about creating 3D things within the browser. I think React 3 Fiber is a great library for those that know React. It makes it a lot simpler to have everything in a component hierarchy like within React. So I'd be really happy if you want to pay my channel a visit if you're looking for more educational content around JavaScript, TypeScript, web development, stuff like that. Thank you so much for watching, and I hope to see you again in the future.